Hi guys, so this is another physics problem. It talks about power and uses a lot of equations that are pretty commonly used in that topic. And I think you guys are going to start working with that concept soon, so I figured this would be a good practice problem to start with. So this problem is talking about an elevator, and it gives its time for the trip, its cruising speed, and its mass. And then it's asking for the average power of the elevator during its acceleration phase, and then that steady state cruising phase of its motion. So the first thing that we're going to do is kind of form a plan and then identify important equations that will help us in that plan. So what I would think that we should do in this scenario is first find acceleration, because that's going to be an important variable later, to find force, and then to eventually find power, because those are all of the variables that you would need to find power anyway. So if they don't give them to you in the problem, then you're going to have to use what they do give you and find them yourself. So once you know what equations you're going to use, we can first start by calculating acceleration. So here it's just that cruising speed and then minus its initial speed, which is 0 because the elevator is starting from rest, and then over 5 because that's the total time it's going to take. And then we find that acceleration is 1.22 meters per second squared. Then we use that acceleration to find the forward-upward motion net force. So basically this is just calculating force using mass, acceleration, and gravity. So we plug in that mass, that acceleration that we found, and the constant of gravity, and then we find that the force is 13,763 newtons. So now we're going to start actually answering what the question is asking. Here we're going to start with part A, which is finding the average power during acceleration. And we're just going to use that power equals force times velocity equation, plug in the variables that we have previously identified the values of, and then we find that power during acceleration is 83,956 watts. So now we're going to do the last part, which is finding part B, the power during the cruising phase of the elevator's motion. So same equation, power equals force times velocity, but now we're going to add that force equals mg. So we have the mass, we have the gravity constant, and then we add the velocity, and we find that power during the cruising phase is going to be 68,817 watts. That's it for this problem. We answered part A and B. We used the power equations effectively. So I hope that this was helpful. If you have any questions, please let me know.